Alright, welcome to this lesson. This lesson is mathematics and the topic is decimals. And this is GH addition. Now, in this lesson, we have some key areas we want to deal with. We look at what decimals are, and then the types of decimals that are available. Then we will look at how to convert fractions to decimals, and then decimals to fractions. Fractions to decimals, and decimals to fractions. Then we'll come to decimal operations, how to multiply, add, subtract, and divide. Then we'll also look at how to round off or round up, and then how to do estimations with respect to decimals. And then finally, we'll look at word problems and its applications of decimals. So for this first half of the session, we'll look at the first 3 points here. What decimals are. We look at types of decimals. We get to understand the place value of decimals. Then we come to converting fractions to decimals, and then converting decimals to fractions. And that will be for the first half. And subsequently, we'll look at the decimal operations and the rest. Okay, so kindly and keenly follow through the video. Where there is a need for you to pause, please pause and solve the question yourself. When you are done, you continue the video and then you compare your answer with the solution that I would give. After each of the questions, the solution would also continue. So kindly pause for each question, solve it yourself like in a regular class, then compare with the answer that would be given or obtained after it has been solved. And this would ensure that you understand. If for any reason you got it wrong, redo it. Don't assume, oh, okay, you know, no. Redo it to be sure that you can do it anytime that you are asked to do it without any support. So kindly pause the video where you are supposed to pause it. Thank you. Now let's ask ourselves, what are decimals? So decimals basically are a way to represent fractions or parts of portions of particular items. For example, if I give you half of the bread, I would typically write 1/2 as the half, 1/2 as the half. Whereas in decimals, I would write 0.5. Now in decimals, we introduce the concept of the dots that would indicate the portion of the decimal that is the fraction. So the number in front is the whole number, and then this is the fraction portion. The fraction portion is not up to 1. So basically, in decimals, you use the dots, you can say a full stop, to show that the portion after the dot is 5 or point. So this one will be 0.5. 0.5. The number before is 0, then point, and then 5. So basically, that is a decimal. Now, inside the decimal, you will have, like I said earlier, the whole number portion, and then you have the fractional portion. You have the whole number portion and the fractional portion. So if I have a fraction that is 2 whole number 1/2, With your previous knowledge, you know 1 over 2 is 0.5. So this will be 2.5. So when you hear the point, the number that comes afterwards is the fractional portion or the less than 1 portion of the decimal. Now the place value. When we talk of place value, we are talking about the strength of a number. For example, if I write the number 21, it is a combination of 20 plus 1. So we'll say that this is the tens. 20 is in the tens, and then this is in the ones. So the tens and then the ones. If it's 2, 1, 5, it is 200. You hear the word 100 there, plus 10 plus 5. So this one is hundreds. The 10 is in the tens. I'm not saying it is tens because it's number 10. It can be 20 for 20 and it's still in the tens like I did earlier. And then the 5 is in the ones. So place value. This is place value for our regular numbers. Now when we come to decimals, we do have place values. Now if you have a number like 5.793, then the system is that the 5 is the ones, the 7 is in the tenths, the 9 is in the hundred, and the 3 is in the thousand, with your th ending. So let me show you that in the next slide. Right, so this is a pictorial or graphical representation. I mentioned that the 5 is in the ones. Then the decimal point comes. Just after the decimal point, we go to tenth. Unlike in the regular numbers where the last number is ones, in the decimal, the number that comes after the decimal point is the tenth. You go to the hundredths, the thousandths, the 10,000ths, the 100,000th. So the th will come like that. Okay. Now up there are the fractional representation. So if you are representing this 7 in fraction, it will be 7 over 10. 7 over 10. So this is place value. This is place value. Now based on that understanding, let's do a trial. Let's do a trial. So this is 32.841. So place value of 4. Place value of 4. I'll give you some 30 seconds to think through before I tell you what it is. So what do you think the answer is? What do you think the answer is? Alright, guess you thought through. So the 4 comes after the 8. We just saw that the 8th portion is the 10th. Therefore, the 4 is the 100th. So the place value of the 4 is in the 100th. With the th, it's not hundreds, but 100th. Let's look at another one. So place value of the number 1. So I'll give you some few seconds to think through. Alright. So what is the place value of 1? What is the place value of 1? Now we know that the 6 is the 10th, the 3 is the 100th, the 9 is the 1000th, the 1 is the 10,000th. So 1,000 and then with the 10,000. So that is the place value of the 1. The place value of the 1. Okay, alright. So let's take some more trials. Alright, so these are further trials. At this point, you will need to pause the video and then solve. And when you are done, you continue the video, you press play to look at the answers from Mind Solutions. So pause the video now and then solve it yourself. When you are done, then you continue the video. So you can pause the video now. Alright, so I expect that you are done by now. So let's go through. The first one is 80.913. We are looking for the place value of the number 3. Now, as we have discussed already, you know that now that the 9 is in the tens, the 1 is in the hundredth, the 3 is in the thousand. So the place value of the 3 is in the thousand. Okay, right. I hope you got it right. Okay, let's look at B. Now B, we have 80.913. We are looking for the place value of 9. Obviously, that is the first number. And that is the 10th. The 10th column. 10 with a th. 10th. That's the place value of the 9. Hope you are getting them right. Now we go to the C. The C has no whole number in front. After the decimal, there is a 0, a 3, and then a 1. Now, although it is 0, it is the 10th. Then the 3 here will come to the 100th. and then the 1 is 1,000. So the 1 here is 1,000. That is its place value. Its place value. And then finally the fourth one. So the temptation is that the 0 here is 0. So when we see 0 as having no real value, we see 0 as having no real value. But that is not the case. Because the 0 has a real value in terms of the decimal. So that is the tens. The next 0 comes in. That is the hundredth. And then the 4 is the thousandth. The 4 is the thousandth. The thousandth. 4 is the thousandth. So that is that. Okay, great. So let's move on. Now we move on. We are going to converting fractions to decimals. Converting fractions to decimals. Now, before we even go on, I hear students say that if they see, for example, 2, they will say 2.481. No. In decimals, we call the numbers as individual digits. So instead of saying this is 2.481, we say 2.481. 2.481. So please take note of that. 2.481. All right. Now to convert fractions to decimals. Convert fractions to decimals. For you to convert fractions to decimals, then you need to understand your long division. You need to understand your long division. I'll be using the vertical method to do that. You need to understand your long division. So if I give you 2 over 5 and I ask you to give me the decimal, you are going to use the long division method. So your 2 is in here, divided by 5. The number that is divided is outside. It's outside. Now, 5 goes into 2. It's not possible. And when you divide 2 by 5 and it's not possible, you bring 0. You don't end there, then you start with a decimal point. Now, once you have the opportunity to bring the decimal point, then it comes with a 0. So 5 goes into 20 is 4. And 5 times 4 is 20. Now, 20 minus 20 gives you nothing. So therefore, the outcome for 2 over 5 is 0.4 in terms of decimals. All right, let's continue. Now let's give ourselves another chore. We have 2 over 3 is a common fraction. Now we want to divide 3 outside, 2 inside. 3 outside, 2 inside. Now 3 goes into 2 is not possible, so 0. Then your point, decimal point. Immediately you add a 0 to this. 3 goes into 20 how many times? If your multiplication table is working, then you know 3 6 is 18. 3 7 is 21, so you can't use 7. It's 3 6. So 3 times 6 is 18. So you write 18 below. You have 2 as the outcome. Now 3 goes into 2. Not possible. So your 0 comes in there. Then 3 goes into 20, another 6. So that makes it 18. 2 with your 0 for decimal. 3 goes into 20, not possible. So another 6. 6, 3, 18. So at this point, you realize that it is recurring. It is recurring. 0.666. It is recurring. So you end there. You end there. Let's try another one. You have 7 over 8. So 7 inside, 8 outside. Now 8 goes into 7 is not possible, so 0 point, then you bring a 0 there. Now how many times would 8 go into 70? How many times would 8 go into 70? Yes, your multiplication table, a quick guess. Are you able to guess? 8 times 4 will be close to 70. 8 times 8. 8 times 8. Now what is 8? 8. It is 64. Now when you subtract this 70 minus 64, you have 6. You have 6. Then you bring your 0. 8 into 60. How many times would 8 go into 60? 8 times 8 was 64. So 8 times 7. 7, 8 is 56. So 7 there, 56. Subtract, you have 44, and then you add your 0 for the decimal. Then 8 goes into 40 how many times? 5, 8, 40. 5, 8, 40. So you have 40 there. You have a remainder? No. Therefore, the fraction 7 over 8 can be written in terms of decimals as 0.875. 0.875. Now we have another trial. 4 questions here. 3 on 7, 8 on 15, 7 over 60, and then 5 over 21. We are converting these fractions into decimals or decimal fractions. Converting these into decimal fractions. So after each question, it will be solved so that we compare. So the first question is A 3 over 7. A 3 over 7. Please pause the video and see if you can solve it. A 3 over 7. Okay, please pause the video now. Alright, so I expect that you have your answer. That is why you are continuing the video. 3 over 7. So we do a long division, vertical method. So 3 inside there, 7 outside. 7 goes to 3 is not possible, so 0 decimal point, then you add a 0. 7 into 30 is 4. 7, 4 is 28. Remember 2, and you add your 0. 7 into 20, 3, 7 is 21. So 2, 7 is 14. So 2 times 14. You have 6. Then you add your 0. Now 7 into 60. 7 into 60. So what is the closest number to 60, or what number will multiply by 7? And it's close to 60. and is close to 60. What are your thoughts? 7 times what will give you close to 60? So 7 times 8. 7 8 is 56. 4, then add 0. 7 into 40. 7 times what will be close to 40. That's the essence of learning the multiplication table. 7 5. 7 5. 35. So this is a recurring number. It will go on and on and on. So we know that our decimal is 0.4285. 0.4285. All right. The B is 8 over 50. 8 over 50. 8 over 50. So please pause the video and solve for this. Please pause video now. All right. Once you are continuing the video, then I assume that you have solved the question. Kindly don't just watch. Solve through each of the questions in this video. So we have 8 over 15. So we are doing the vertical long division. 8 in here, 15 outside. Now 15 into 8. Outrightly, you know it is not possible. So you put 0 point, you bring your 0 here. 15 times 4 will be close to 80. That's why I said double digits. So let's take it in bits. 15 times 2 is 30. 15 times 4 is 60. 60 is close to 80. What about 15 times 5? Now the 60 plus 15. Because 15 times 4 is 60. So if you do 15 times 5, you just add an additional 15. Now make it 75. So 5 there. So 15 times 5 is 75. Subtract, you get 5. Then add your 0. Now 15 into 50. So you know 15 times 3 is 45. So 3, that is 45. Subtract again, you get 5, 0. 15 times that will be another 3. 15 times 3 is 45. So you realize that it is going to be recurring. To be recurring like that. So the next one for 8 over 15 is 0.533. Recurring 533. It will be repeating after that. 3 repeats itself. Great. Let's go to the next trial. This question is 7 on 60 or 7 over 60. 7 over 60. We use the vertical method. You can use any other method you are comfortable with. So 7 here, 60 there. Now 60 into 7 outrightly, you know it's not going to work. So 0 point, add 0. 60 into 70 is 1. 60 times 1 is 60. You do a subtraction, you have 10. You bring your 0. Now 60 into 100 is 1. Another one here, 1 times 60 is 60. you have 40. Then you bring your 0. 60 into 40. Now, take off the zeros after 1 0 after each of the numbers. You'd have 6 and then 40. With that, you'd be able to get the answer or easily guess the answer. How many times will 6 go into 40? It's the same as how many times will 60 go into 400. You are taking off a 0. You are taking off a 0. It is like this. Let me write it here. 400 over 60. Doing an outright division is difficult, so you take off a 0 each. So you have 40 over 60. The answer is the same. Alright, so 6 into 40. You know that 6 is 36. 6 is 36. So 6, so that 40, 400 divided by 60 is 6. Then 60 times 6 is 360. Subtract, you have 40, you bring your 0. The same thing will happen, it will be 6, 360, and then you have 40. So you pause there, our answer is 0.1166. That's the decimal for 7 over 60. The decimal for 7 over 60. Now let's look at the last one. Right, the D is 5 on 21, or 5 divided by 21. Converting that into a decimal. So pause the video at this point, solve first, then allow the video to play and you compare answers. So please pause. Okay, great. So after solving, what did you get? Let's solve it together. So we have 5 divided by 21. So 5 in here, 21 outside. Alright, so we have 0 dots. Because 21 will go into 5, it's not possible. So 0 dots. You bring your 0 to it. 21 into 50. 21 into 50. That will be 2 times. 2 times. 2 times 21 is 42. You subtract, you get 8, you bring your 0. 21 into 80. Obviously, 4 times is not possible because 4 times would be 84. Would be 84, so it's not possible. So how many times? Then the next number below is 3 times. 3 times. 21 times 3 is 63. 63. You do the subtraction, you have 17. Now 21 into 17. So after the 17, you bring your 0, sorry, you bring your 0. So 21 into 170. 21 into 170. Let's do some computations and see. 21. Let's start from say 6, because 6 we know is 120. So it's 126. 21 times 7. 717. 2740. Let's see if we add 21, what would the answer be? That would be 861. Okay, so that means that we can go to 21 times 8, because we did times 7 and we got 147. Adding 21 means you enter times 8, so that is 168. So 21 will go into 170, it's 8 times. It's 8 times. 21 times 8 is 168. We have a remainder of 2. And having a remainder of 2, you bring 0. 21 into 20, not possible. Once you've already added the regular 0, you add all numbers, it's not possible. That means you have to add a 0 there and then count that 0. Before you do 21 into 200, 10 will not do because 10 will be 210. So then definitely 9 should be doing a good job. So 21 times 9, 919, 2980, 189, 189. So 200 minus 189 is 11. So we'll end there. So the answer for this is 0.23809. 0.23809. And that is the decimal. 45 over 21. Great. So having gone through this, then we can move further to a different discussion. Great. Now we move on to converting decimals, this time around to fractions. Decimals to fractions. Decimals to fractions. All right. So let me give a heading. Decimals to fractions. Now this one is a little bit easier than fractions to decimals. So for example, if I give you 2.1, this is what you do. Now the 2 is a whole number. So you can have 2 whole number, then you look at the number of numbers after the decimal point. You have only one number. So you put the number 1 under the decimal point, then a 0 under the number after the decimal point. So in effect, you have 2 whole number 1 over 10. The original question was 2.1. Now for the same thing, 2.1, you can also choose to make the numerator a combination of both the decimal and the whole number. So you put 21 there over, now like we did for the other one, you put a 1 for the decimal point and 0 for the 1. So you have 21 over 10. 21 over 10, which is also the same as 2 whole number 1 over 10. So either ways is acceptable. Let's do another one. 3.05. 3.05. Now, if you want to go the first way, it is 3 whole number. Now let's go deal with the decimal portion. You put 1 under the decimal point, a 0 under the first number, another 0 after the second under the second number. So in effect, you have 3 whole number, 0.5 over 100. 3 whole number, 0.5 over 100. Now in effect, it is 3 whole number, 5 over 100. 3 whole number, 5 over 100. The 0 that comes before is not needed. 3 whole number, 5 over 100. In same vein, if you have 3.05, you can choose to make it 305. Then you go and look for the denominator. Now, what will the denominator be? The same thing. The decimal point, we take 1. This first digit will bring the 0. The next digit will bring the 0. So you have 305 over 100. 305 over 100. 305 over 100. So this is how to convert decimals to fractions. Decimals to fractions. Decimals to fractions. Alright, so let's go to some trials. I have 4 trial questions. A is 0.036, B is 1.204, C is 92.05, and then D is 18.725. 18.725. Great. Now we're going to solve them one after the other, and then you would do same, just like we've done in the previous ones. So the A is 0.036. 0.036. So pause the video now, solve it, and then continue the video to compare your answers. Alright, so thanks for pausing your video. So let's solve it together. We have 0.036. 0.036. Now, in this one, there is no whole number. So you look out for the denominator. Like I said, you put 1 under the decimal point, and under each of the numbers you put a 0. So in effect, we have 36 over 1000. Now you can choose to reduce it to its lowest term because you are looking for the fractions. Let's try how far we can go. 2 go into 18, sorry, 36 is 18. 2 goes into 1000 is 500. You also go further. 2 goes into 18, 9. 2 goes into 500, 250. Now 9 and 250, you can't go further because the only number that can divide 9 is 3, but 3 can't divide 250 because that's a 0 or an even number at the end. So we are not able to divide that. So that's the final answer. Okay, great. Hope you got it right. Okay, let's go to the next one. In this one, we have 1.204. 1.204. So try your hands on it by pausing the video, and then when you are done with your solution, you would continue the video and then compare your answer. So please pause the video now. Alright, so we have 1.204. So like we did, you put a 1 under the 1, and a 0 under each. So it's either you are writing one whole number, 204 over 1000, or writing 1204 over 1000. 1000. 1204 over 1000. 1000. So that is the fraction for that. You can reduce this to its lowest term. They are even numbers, so you can reduce to its lowest term. Starting with 2, you have 602 on 500. Another 2 will give you 301 on 250. Now, at this point, doing it mentally, you can pause on that. Let's go to the C. So in C, you have 92.05. 92.05. So same, you put 1 here, you put 0, 0. and then you find the outcome. So you should be pausing and solving yourself, then you compare answers. Alright, so I'm sure you've paused and solved. So the outcome for this is that 92 whole number 0.5 over 100. That is if you are using the first way. Now the 0.5 is 92 5 on 100. Okay. Now equally you could do 9205 over 100, and it is also a fraction. But as always, we prefer it to be in the mixed form than the improper. The mixed is where there is a whole number in a fraction. The improper is where the top number is bigger than the down number. Alright, the last one, 18.725. Realize I didn't say 18.725. No, it is 0.725. You call out the numbers individually. 725. So you have to pause the video and then try your hands on it. So please pause video now. Alright, so I assume you paused the video and you solved. So let's solve it together. So 18.725. You have 0 here, 0 here, 0 there, then under the decimal you put 1. So in fact you have 18 whole number 725 over 1000. Similarly, you can write 18725 over 1000, and the outcome is still the same. The outcome is still the same. Okay, right. So we move on. Alright, so this is how far the time would send us. Make sure you understand this thoroughly so that application would be easy. So I'll send some questions to the platform for you to solve. Thank you very much.